The universe is filled with countless secrets and unanswered questions. The farther we explore the depths of space, the more mysteries appear that modern science still struggles to explain. Today, we are going to take a look at two extremely unusual cosmic objects. They are often described as planets, although even that classification is somewhat questionable. One of these objects is called CFBDSIR 21490403. Or more simply referred to as CF1. This strange body may be one of the most puzzling objects discovered in the known universe. It almost feels like a mystery waiting for us to uncover it. When astronomers first observed this unusual object, they believed it was a rogue planet. A rogue planet is a planet that has been gravitationally expelled from its original star system. Such an ejection could happen due to interactions with other planets or even the influence of a passing star. This particular object lies roughly 100 light-years away from Earth. It was discovered in 2012 by an international group of astronomers led by Philippe Delorme. Early observations suggested that its mass was somewhere between 5 and 9 times that of Jupiter. However, there was something strange about it. The object appeared to be hot, and that should not normally be the case, but we are getting ahead of ourselves. Let's examine the story in the proper order. In general, these so-called orphan or rogue planets are not particularly rare in the universe. They are sometimes placed into a category known as planemos. Scientists believe that there could be a large number of such objects scattered throughout space. Some of them might even exist closer to Earth than this mysterious traveler. However, they are extremely difficult to detect. Most of them emit little or no light at all. When astronomers discovered that this potential rogue planet was emitting heat, the idea that it was simply a planetary object became uncertain. To better understand the situation, scientists turned their attention to brown dwarfs. Brown dwarfs are objects that fall somewhere between planets and stars. They are too small to be considered true stars. Their mass is not large enough to create the pressure and temperature required for hydrogen fusion, the reaction that powers most stars. For hydrogen fusion to begin, an object must have roughly 80 times the mass of Jupiter. That equals about 8% of the mass of our Sun. But even an object with around 13 times the mass of Jupiter can start limited thermonuclear reactions involving lithium and deuterium. Because of this, brown dwarfs are usually defined as gas objects with masses between 13 and 82 times the mass of Jupiter. They are essentially larger than planets but smaller than true stars. If the mysterious object CF21 has less than 13 Jupiter masses, which current observations suggest is the case, then it may indeed be a rogue planet similar to Jupiter. Such a planet would have been thrown out of its native system and now drifts quietly through space not too far from us, at least on a galactic scale. But the story becomes even more intriguing. CF21 emits radiation in the infrared spectrum. This means the object is still releasing heat into space. A young planet that has only recently formed can glow with heat and may continue doing so for millions of years while it slowly cools. During the first observations after its discovery, scientists noticed that it seemed to move together with a nearby group of stars known as the Doradus moving group. This conclusion was based on its apparent position near that cluster. Because of this, researchers initially assumed that the object originated there. The stars within the Doradus group are relatively young and likely formed around the same time. In the distant past, gravitational interactions between these star-scowled have disturbed planetary orbits. Such interactions might have ejected a planet from its original system, creating an isolated object like this planemo. If CF21 truly came from that stellar group, then it would probably be a young planet that simply has not cooled down yet. However, later and more detailed observations told a different story, using instruments such as the European Very Large Telescope in Chile, the Canada-France-Hawaii Telescope, and the Spitze Space Telescope. Astronomers applied the parallax method to measure its distance more accurately. This technique calculates distances by observing objects from different positions of Earth in its orbit around the Sun. The results show that CF21 is actually about 130 light-years away from Earth. This is significantly farther than scientists initially believed. Originally, they thought it was roughly the same distance as the nearby star group. around 75 light-years away, but now it appears to be much farther from any active star-forming region. If this object truly lies in such an isolated location, then it cannot be very young. In fact, it would have to be at least 500 million years old. If it really is a rogue planet, it is difficult to explain how it could exist in this region. As far as we know, planets form in the disks surrounding stars. If CFBDSIR traveled from the Doradus group, which lies about 55 light-years away, then during such a long journey it should have cooled significantly. Yet observations do not fully support this idea. The temperature of this mysterious traveler is estimated to be more than 400 degrees. And if the object is actually farther away than originally thought, then it must also be brighter than we assume. Greater brightness would suggest a larger mass. Refined calculations now estimate its mass to be somewhere between 2 and 13 Jupiter masses. The upper limit is just enough to trigger a minimal thermonuclear reaction involving lithium. Still, most estimates place its mass closer to about 7 times the mass of Jupiter. So, what exactly are we looking at? Additional observations revealed another interesting detail. The object contains a relatively high amount of heavy elements. That is, elements heavier than hydrogen and helium. Typical brown dwarfs usually contain fewer such elements. Yet the amount detected here is still too small for the object to clearly be classified as a planet because of this. Scientists cannot state with complete certainty what this mysterious body truly is. Nevertheless, most of the available data points toward it being a rogue planet. More observations will be required to fully understand the nature of this unusual object. Research is ongoing. As our knowledge of the universe continues to grow, we will eventually discover the answer. For now, its true identity remains unknown. Perhaps you, dear viewers, have your own ideas about what this object might be. Feel free to share your thoughts in the comments. I would be very interested to read your opinions. And now, let's move on to another equally strange and still unexplained object. KLT11b is a giant planet often compared to a ball of styrofoam. Yes, that description may sound unusual, but the comparison helps illustrate its incredible properties. This enormous exoplanet was discovered only recently, and its characteristics surprised astronomers. The planet lies about 320 light-years away from Earth. It is extremely inflated. Its size is roughly 40% larger than Jupiter, yet its mass is only about 1/5 of Jupiter's mass. Because of this unusual combination, its overall density is incredibly low, similar to the density of styrofoam. Of course, the planet is not literally made of foam. The comparison is simply a way to describe how light and diffuse it is. Among the exoplanets whose mass and radius have been accurately measured, this strange world ranks among the 3 lowest in density. Studying such objects may help scientists understand how these unusual planets form and how they evolve over time. KLT11b also stands out for another reason. In astronomical terms, it will eventually disappear. The planet orbits a very bright star called KLT11. This star is currently transitioning into the red giant phase. During this stage, hydrogen burning begins in shells outside the star's core. As a result, the star's outer layers will expand dramatically. According to researchers, within the next 100 million years, the atmosphere of KLT11 will expand outward until it eventually engulfs the planet KLT11b. Since the planet completes one orbit around its parent star every 5 Earth days, it lies extremely close to the star. This means the eventual absorption of the planet will occur relatively soon, at least by astronomical standards. However, there is a positive side to this situation. KLT11 is one of the brightest known stars in the southern sky. Because of this brightness, astronomers have an excellent opportunity to study the atmosphere of this unusual planet. Its ultimate fate arrives. One of the most common methods used to discover exoplanets is known as the transit method. When a planet passes in front of its parent star from our point of view, the brightness of the star decreases slightly. This small dip in brightness signals the possible presence of a planet. In the case of KLT11, the change in brightness was extremely small. At first, astronomers could not immediately confirm that a planet was responsible. Using the KELT telescope system, which includes two robotic telescopes located in Arizona and South Africa, astronomers conducted further observations. Working Together like a giant pair of binoculars spanning the Earth, these telescopes helped gather additional data. Astronomer Joshua Pepper from the University of Pennsylvania explained that confirming the discovery was quite difficult. Early observations showed only a faint hint of a planetary transit. The brightness of the star changed be less than 0.3%. Obtaining clear confirmation rate many additional observations. Fortunately, later studies finally confirmed the existence of this unusual exoplanet. Scientists are now attempting to understand why KELT-11b is so extremely inflated. What physical processes cause such an incredibly low density? Researchers are also studying the parent star itself in hopes of learning more about how stars behave near the end of their life cycles, and of course, I'm eagerly waiting for the results of these future studies. Until then, I will continue preparing more fascinating episodes for all of you. Thank you very much for your attention. See you again soon. My dear friends, if you have ideas for future episodes, please leave them in the comments below. The author of the best suggestion may even have their name featured in a future video. And don't forget to leave a thumbs up.